So now that we have saved this file, let's go ahead and use it. I will grab this path over here and I will just copy this and go up a level. And to use this proxy geometry, let's go to our geometry node for the R&D ground. And inside Redshift object, I will go to the proxy tab and I will set enable proxy file over here. And inside the proxy file name, I can now simply paste my path and point to where I saved the proxy from this FX geometry. So this will point to our rs ground $f4.rs. And now that this object is pointing to a file on our disk, we actually don't need to use this object merge inside, so we don't really have to have any geometry inside the object context. So I can just delete this node here. Unfortunately, this still needs an object to have the render flag set to on, and I will just drop down a null and leave the render flag for this turned on, which it is by default. So this is just a small gotcha by using the Redshift proxy workflow, is that you can set up the proxy at the object level over here, but you still need to have a node with the render flag set on in order for this to work. So I just have a null here. Let's go up. And even though we are not displaying anything in the viewport, our render should recognize this file path. And before we create a render, let's make sure that the proxy materials for this rs proxy option here, this is set to from obj node. So now this will look to our render tab where we have this material set up here. And now we can go to the Redshift render view and let's create a preview render. So we can see that the geometry is working and our Redshift proxies were saved. And let's go to the light and maybe set the saturation for this to 0. And maybe drop down the exposure a bit, just for now. And maybe we will turn this back on later. Let's take a look and see how we can make the material work. So inside the material where we created the rs ground, let's drop down that triplanar node. And let's see how we can map our textures to the geometry. So from this triplanar, let's set the albedo, and I will actually turn off the rendering for now. I will set the out color for the albedo inside the texture and place this inside image X. And by default, this has this option that says same image on each axis. So basically this means that all of our image X, Y, and Z will have the same image that links to this rs texture node over here. And from here, I will plug this inside the diffuse color. And maybe I can actually just override this material for now, and I will plug this directly into the surface, just so we can preview only how this albedo texture will be mapped onto our geometry. And here we can determine a scale, and I will maybe start with a lower scale value, so I'll just drop this down a bit. And projection space type, and this is very important, this has to be set to reference. So when this is set to reference, this will now take the rest attributes, so the rest position and the rest normals that we generated earlier before we saved this Redshift proxy, and it will use those coordinates and attributes to make our texture stick to the geometry even when it moves. So whenever you are working with animated geometry and you want to use the triplanar projection, you will need to set the projection space type to reference, and you will need rest attributes on your geometry. So let's press play and see how this will look. Alright, so we can see that this is how it looks so far, and maybe I can drop down the scale. And let's settle for a value that kind of makes sense. So we can see that we are working with really low values. Maybe 0.05 should be good. And from here, what I can do, so let's say that I'm satisfied with this, so I will stop the render for now, and I will want to create 3 copies of this, or rather 2 copies. So I will right click on this triplanar, go to actions and create reference copy. And let's plug this the roughness inside this triplanar, and then back to our roughness output, or rather input. And then I will just duplicate this triplanar, and we want to do the same for the normal texture. So plug this inside here, and then this goes inside the bump map, inside the input, and now we can plug the material inside the surface, and all the textures should work now and be properly mapped onto the geometry. Alright, and now I can go back inside the object, and let's go to my light and set the exposure back to 0. And maybe even increase the intensity maybe to a value of 2. Okay, so now we have the texture being mapped with the triplanar projection, and it's sticking to our objects when the pieces start to move. And the geometry from the Redshift proxy is working. So we can see that as I reset this render, we can see how fast this goes from the speed to the first pixel on the screen is just a few seconds, and if we didn't have the Redshift proxy set up, it would take maybe 10 or 15 seconds until we get something on the screen here. And because we will be creating multiple different renders for each of the paths, we will want to use the ground geometry as a matte element for each of the paths. So each time that we render any of the passes that we will create further from here, we will skip the loading time for the geometry for each of the renders. And since we will be creating like maybe 8 different passes, this will save us really a lot of time in the long run. So it's very important that you set up this Redshift proxy for the ground geometry. So we will actually be leaving the ground as it is for now. And in my out tab over here, and if you don't have this, you can just create a new paint tab, and I will just set this to out. And for this Redshift drop, let's rename this to ground. So we will use this to render our ground, and we will be creating different Redshift drops for all of the other elements and chain them up together so we can render them at the same time. And I will show you how to do this in a minute. And inside this ground render node, we will go to, let's make sure that this will be rendering the whole frame range, so from 1 to 200, and we will run into a problem here. If I were to go to frame 140 and let's turn on the render, we can see that this is working and this is rendering fine, but if I were to turn this off and go to maybe frame 146, if I press play, then we will have nothing showing. This is actually the background for our dome light. And on that node, let's actually just go to our object level and let's select this dome light, and in the environment tab I want to set this background option to off. Alright, so we are not rendering the background as well. But we can see that we have no geometry from frame 140, and this is because inside this render ground node where we have our proxy set up, we have cached only up until frame 140. So where we set up this proxy output, we selected only to 140 because after 140 basically the geometry will be frozen and there's no sense in saving further frames from 140. And if I go up, we have to somehow tell this proxy file name to look for the path only up until frame 140. So instead of using this $F4 expression over here, what I can do is I can do double quotation marks, and in between I want to add an expression. So this expression will say that if, and in parentheses I will say that if the current frame is less than 140, then just give me the current frame value. If this is bigger than 140, then just set the frame to be 140. So this is just the shorthand version of the if condition that we can add inside Vex or any other place. So again, this is basically saying that if the current frame is less than 140, then just give me the frame number. If this is bigger than 140, then just set this to be 140 and keep it this way for as long as this is no longer true. So now if I middle mouse click this proxy file name, we can see that this will now increment from 1 to 140, and then it will stay at 140. And we also need to use the $F4 version of this number. So if we check, we can see that we have here the format with 4 digits basically. So let's go back to our expression and let's put this entire if statement inside a pad0 function. So I will say pad0 and open parentheses and use value of 4 and then period, and then use another end parentheses over here. So now with this expression we should match the formatting that we have saved this file. All right, and we can check and we can see that this is incrementing. And now if I preview maybe 106, we should have our geometry. All right, and also if I preview a frame after 140, so let's go to 160, we should also have the geometry. Okay, and we can see that we can render 160 as well. All right, so let's go back to our Redshift render and let's select this ground and make sure that this is pointing to the camera in the scene, which is cam1. For the output, we can select a folder here, so let's select it. So I will place this inside an RNDR folder, inside a ground folder, and the file name I will set to be ground.f.exr. So we have to make sure that we save this as an EXR. And we can go inside the AOV manager, and we also want to export a couple of AOVs for this as well. So let's hit the plus sign and we will export the diffuse light, and let's create another, and this I will set to specular lighting, and let's select another one for reflection. And finally I will want the position pass, so the world position. So this will be very important later. And let's go to the Redshift tab and let's set some settings here. So I will leave most of these settings as they are, but I will just disable global illumination. And the only thing left here to do is inside these object tabs, I want to make sure that for this ground node, I will only render the ground geometry and our dome light. So let's go to the object and let's select this R&D ground and paste this over inside here for forced objects, and I will get rid of the candidate objects. And for the candidate lights, I will grab this light dome, and let's go here and force lights, place this here and get rid of the candidate lights. And now we can take care of our other renders.